Okay, well, I'm going to go ahead and get started. And my name is Jim Brettman. I'm the product manager for Jim Myers & Sons Delta Separation product line. Hopefully, everyone can hear me and can view my screen well and see my screen and the cursor there, the colored cursor. We're supposed to and are approaching some 30 to 40 people around the country in on this call. So again, I appreciate your time and value it. To start with, my mission is to spend about 20 or 30 minutes, 20 to 25 minutes max, to discuss submerged grit collector screw systems employed at municipal treatment plants. I'll be going through a short PowerPoint presentation, and we'll then show you tools we have to help you and hopefully answer any questions you might have at the end of the presentation. My goal is at the end of the presentation you'll feel good that you have a fundamental knowledge needed to know if this equipment is a good fit for your project needs, and to know where to go if you need more information. With that, I'm going to go ahead and get going. These are the topics I'll be discussing today. I'm going to jump right into there we go. Couldn't get my stuff toggled. So we'll be discussing submerged grit collector screws. It's a classification process. We're removing grit from the process. We are conveying and separating grit from the water in the basin. Certainly an abrasive application, I'll hit on that further. Today we'll be focusing on the horizontal submerged grit collector screw conveyor systems. Typically they're located in aerated grit tanks. We're conveying grit from the tanks to a trap or a sump or a well, perhaps in the same basin as the screw, perhaps on the other side of a basin wall. Further conveyance of the grits required via grit pumps or airlift pumps. Unlike the grit classifier system, the inclined grit classifier system you see in the bottom right corner, which, as you all are familiar with, is partially submerged, inclined, and is conveying classifying the grit and conveying it above grade directly to a dumpster with no further conveyance required. So what we'll be addressing here is three different types of applications, configurations: a wet chain, dry chain application, and as well as a couple of direct drive applications. You're looking on the pictures you're looking at on this page are, and I've tried to label them. Obviously, that's a drive system in the upper right. I'll be talking a little bit more about later. But here's a wet system, meaning the chain is inside the basin. It's wet. There's the driven sprocket you can see back there. Sorry about the small picture. You can see the slope of the basin floor and how it's obviously directing the grit towards the conveyor. Here's another wet application. A little bit of a dark drawing, but if you look closely, you can see the screw auger penetrating the wall. So this is a separate basin from the grit collection basin, and this is where the driven sprocket is. And again, this is a wet application. It's just drained right now, of course. So that's it kind of gives you a visual of a wet. This is a dry chain application, as you can clearly see. You've got stuffing boxes, pillow block, driven sprockets, and chain. I'll be talking a little bit about that. Here's another application, a large driven sprocket with split hub, a split hub with segmental UHMW teeth, and chain, pillow block bearing. On the other side of that is a stuffing box, of course. And then next is a direct drive application, which, and I'll be showing you drawings of these. I'm moving kind of quickly, trying to get a lot of information in. But here, no chain and sprockets apply. A wall sleeve and stuffing box is employed. Here's another one, a dry application, and you're seeing right here, a stuffing box. This right here is a AquaGuard torque limiter switch. While we're looking at the picture, I'll mention what it is. It's basically just a mechanical circuit breaker, if you will. Y'all might be familiar with that. And then, of course, you got your pillow block bearing and a chain coupling. Here to the left is a good photograph of a stuffing box, which I'll be chatting about a little bit later. To the far right is a top and bottom photo and drawing cutout is a a wet application where a right angle gearbox, submerged right angle gearbox is being employed. The drawing you can see down here. So this is a wet application. So a direct drive, you can have a direct drive like in the middle picture there, or you can have a submerged direct drive right angle gearbox. And now I'm going to be going through some design considerations. You can see the items on the left. I won't read them off to you. I will be going in somewhat that order, but as the pictures help facilitate it, I will address a couple of them not necessarily in order. So shafted versus shaftless screw conveyors. Well, shafted is certainly the most common, but not the only way to go. There are pros and cons, as always, to both. Keep in mind, the rotation of the screws it's slow, typically 10 RPM or less, not uncommon to see 6. And to give you a visual while I'm talking, is on the far right is a shaftless conveyor. You can see it's a dual spiral if you look closely, and you can see it's a wet application because you've got the driven sprocket down there at the end. You can see some hold down bars located right here. See a couple of hold down bars located they're typically 4 feet long and located about every 12 feet. To your left is a shafted screw conveyor with hard face welding, you can see. And then troughs, I'll be talking about them. So let me just talk a little bit more about shafted versus shaftless. Of course, with shafted, you have no wear liner. It does require hanger bearings when the length is over 18 feet or so. Those bearings, however, offer structural integrity that as well as support so that spiral wear on shafted conveyors is reduced because the deflection is kept to less than 0.25 because of the bearings, and therefore there's not as much wear on the OD of the flights. The reality of how shafted screws work in the trough, the grit forms between the OD of the spiral and the ID of the trough. A layer of grit forms, and in effect forms a false liner of grit, if you will. That's what happens with the shafted. With shaftless, not the case, of course, right? Shaftless is something is sacrificial in a shaftless application, whether that's the auger or whether it's the liner. Typically, of course, shaftless requires no hanger bearings, which is a pro. A wear liner is required, and typically a wear liner is either stainless steel or A36 steel. In 4-foot sections, it's often called a subliner, where a 1/2 inch thick by 2 inch wide Hardox wear bars are stitch welded to the subliner, and that subliner is tacked into the trough, if you follow that. So that's the most common wear liner for shaftless screw conveyors. Shaftless screw conveyors, when they get long, the longer lengths require field welding, something the shafted does not require. Let me see. Of course, you have to replace the wear liners at some point in time, depending on the application. The larger the diameter gets with shaftless, and the longer it gets, the greater the rate of wear, as you might guess, on the liner. It kind of makes sense. I'm going to go ahead and talk materials a little bit while I'm on this slide. Again, it's a very abrasive application, right? Typically, flights are 3/8 inch thick, minimum. Typically, it's abrasion-resistant alloy steel with a minimum Brinell of 220 or so. It certainly can be stainless steel, but if it is stainless steel, because of the abrasion design parameter being so important, the face needs to be hard face weld. And you can kind of see that on this screw. You can see the hard face welding, which has a Brinell of greater than 400 to, again, deal with the abrasion factor. The troughs are typically 12 feet long. They typically have embedment anchors. You can see they're basically bolts, if you will, welded to the outside of the trough. I'm up at the top here. Or there can be angles. The whole point is it's for embedding into the grout, and the trough serves as a form for the grout as well. Troughs can be bolted. You can see these are bolted. The sections are bolted together. They can also be welded, or they can only be welded if you want to butt weld them. But typically, they come as shown in this picture. Concrete troughs are okay as well. You can put a screw in a concrete trough, but typically the forming of the trough, a SEMA-style trough or a flared trough for these applications, help direct the grit better, rather than it just being in a rectangular trench, I'll call it. Let me talk a little bit about the bearings. Particularly, I'm looking at the hanger bearings here. You're looking at the picture on the left. I'm kind of circling this whole half of the page, if you will, is in regard to the intermediate hanger bearings required on shafted screw conveyors. In the bottom picture, you can see that one's pretty worn. We're needing some help there. There's a good example of replacements needed now or certainly in the near future. Typically, a SEMA 226 type hanger bearing is employed. And by the way, SEMA hanger bearings and sleeved wall bearings are the tried and true method for these grid applications. Been proven over decades to last. That these SEMA 226 hanger bearings, here's kind of a cutout. Here's a cross section of, you can see the trough with the embedment anchors, the support for the SEMA bearing, which is typically stainless steel. And then you can see the bearing down here. And it is typically water lubricated or water flush, not grease, but water. Typically hard iron bearings and liners are employed in these hanger bearings. Life expectancy, 6 to 12 months minimum. It depends on the application, size, hours of operation, etc. So that's kind of trying to give you a visual of the. You can see the water line coming down from above, typically from above grade, of course. On the right side is a stuffing box. Stuffing boxes are something that Jim Myers and Sons, we know, we've learned a lot. Starting back in 1980, we've provided horizontal paddle wheel flocculators. Y'all are probably aware. We are the leader in the industry in that and just have thousands of these flocculators out there and have learned a great deal over 40 years and have improved as well our stuffing box arrangement, which is, you can see a drawing on the bottom right side and a visual, a 3D visual on the upper right. The stuffing boxes quickly are fabricated carbon steel or T304 stainless steel with bronze bushings and retainer glands. There's 6 rows, minimum 6 rows of packing material. Here you can see 4 rows here, and then there's a lantern ring, and then 2 more rows of packing material with a grease fitting, kind of hard to see, but a grease fitting right here for greasing. The packing is adjustable externally on the dry side, which is on this side of the stuffing box. And we supply, there's a wall sleeve. You can see this wall sleeve with a water stop right there. And then you've got the stuffing box itself right here. Here are 4 link seals for sealing the ID of the wall sleeve to the OD of the stuffing box housing. So that's the design. That's the general. I don't want to get into too much detail, but generally that's the design of the JMS stuffing box. And now what I'd like to do is spend a couple of minutes talking about the drive system. And while I'm at it, I'll talk about, I'll brief you on the chains and the drive and driven sprockets as well, the design considerations there. But while I do that, what you're looking at here is this is a wet application, right? We've got the spiral here, we've got the sump here where the grit is collecting. We've got the driven sprocket and 2 pillow block bearings, one to the left, one to the right. Of course, that's where the force is, right? The force is right where that, the vertical pull is right where that driven sprocket is. So it's good to have support to the left and the right. Is a solid design. Over on the right is a wet application as well. A little bit different design though. Here we've got a wall support. Here's the drive driven sprocket. And then the next support you see is an intermediate hanger bearing over here. So it's key that the unsupported length between bearings is such that we achieve the deflection tolerance in order for this sprocket and system to operate as intended and to operate for the life it's expected. So let's talk about the drive. The drive is typically over in the bottom left corner. By the way, that's just a top view of the driven sprocket and the two pillow blocks to the left and right. The drive systems typically is a shaft-mounted gear motor assembly, which includes a motor, a gear reducer, and a drive base with stainless steel adjustable base plate that includes a leveling plate and rods and nuts so that we can adjust the elevation and therefore the tension in the chain. If the chain is too long, upon installation, you remove a link or two or more in order to get the chain the proper length so that you're within the tolerance of the adjustment in the leveling plate of the drive system. And that's how we adjust the drive tension. Of course, there's a chain guard on them as well. So while I'm on this drawing or this slide, I'll go on and address sprockets. Sprockets, they offer from a drive to a driven sprocket offers a 3-to-1 gear reduction advantage to allow a smaller gearbox. Keep in mind this, we're going from the RPM of the motor, typically 1800, and we're going all the way down to less than 10 RPM, sometimes 6. So we're really needing to reduce it. The 3-to-1 assists a lot, saving cost in their gearbox, operational costs, energy costs, size. The drive sprocket, typically, and let me see, I'll go back in a second. The drive sprocket is typically a cast iron hub with UHMW PE teeth. Machined, it's engineered and machined to accurately engage the chain. The driven sprocket, if you recall this picture here, the driven sprocket is a split machined hub. And it's split, of course, so that you can remove it and not have to remove the shaft. You can replace it and remove it without having to remove the shaft. And it is a segmented UHMW teeth. By segmented, you can see we've kind of got pieces of pie here kind of thing, and pieces end up being the complete system. While I'm here, the drive sprockets typically are equipped with a shear pin, keyed for torque, as to provide torque overload protection. You know, the way it works is when the shear pin failure occurs, a trip lug pops out of the sprocket and a limit switch is engaged and sends a signal to the drive system to shut down. So that's one of the methods for torque overload protection. And again, that AquaGuard torque limiter was another option. There it is. That torque limiter is another option for torque overload protection. And how about the chain? The chain is, I'm just going to go back to the slide I was on. The chain is an engineered chain. Typically, it's an HB78 stainless steel chain, typically 403 stainless steel. 403 is not as corrosion resistant as 304, 316, but it is stronger. This chain handles typical workloads of 3,300 pounds with a 24,000 ultimate strength load. You know, why not non-metallic? Non-metallic certainly offers corrosion advantages. We know that. But it's not typical for this application because of the load requirement. Kind of a rule of thumb, or typically, if you've got greater than a 2 horsepower, then you probably need a stainless steel chain versus a non-metallic. Okay, so I'm going to go ahead and I got one more slide here. These are showing additional arrangements, and I'm just hoping that visuals speak a lot of words for you and help you out. On the left side, you can see the bearings, you can see the support here. You've also got a wall bearing here. You ideally do not, you got a stuffing box in here, of course. You don't want to have vertical force or you want to minimize the vertical force on your stuffing box. So to have a pillow block and support on the dry side and the wet side of a stuffing box is the right design. In the middle here, you can see we've got a screw penetrating the wall like we did in that picture early in the presentation. The screw is penetrating the wall and discharging, conveying the grit from the basin over here, from the basin to the left and into the sump pit here. We got a couple of concrete piers where we've got our pillow block bearings and our driven sprocket up to our drive above in a wet application. The drawing on the right is a cutout of the same thing, that I showed you earlier, which has the right angle gearbox in the grit area, right down here in the sump area, and you can see that as well. And it is supported from the wall, and then we've got the other support over here at the intermediate hanger bearing. Maintenance. As far as maintenance goes, the gearbox, first 500 hours, maintenance on the gearbox, replacing the oil, and then every 6 months, and with synthetic, you can even stretch it out further than that, up to 2 years. The hanger bearings we talked about are water lubricated. And then the bearings, the spherical roller bearings, the wall bearings, which again, typically have hard iron liners or bearings, require grease. And those bearings, again, every 6 to 12 months minimum of life expectancy. That's about it. That's the extent of my presentation. I wanted to share with you that we've got the JMS website. We've got a marketing team that spent a lot of energy, and we're proud of our website, and it's got learning center topics, lots of information that we continue to fuel it with on an ongoing basis aggressively. There's a lot of information there that you might take a look at it if you haven't already. Again, learning center and content marketing, and we've got a drawing library. So if you should have an application and a need for CAD drawings, there's a good chance that we've got a drawing readily available for our reps and our engineers to use in their business. And that is about it. I've been flipping my lips for a while here, so I'm going to unmute, and I should now be able to hear you, and tossing out if there's any questions. I'm do my best to answer them. Well, I certainly hope I've brought some information and new knowledge to you, and certainly ask you to touch base with our representatives or call our office direct if there's anything we can do to help you.